All right, today we're going to jump into some rational inequalities. So similar to what we just did in the previous page, however, we may no longer cross multiply. No cross multiplying. In this case, the inequality does make a difference, particularly when we may miss out some things where, I guess as we look at the graph, I'll talk about why cross multiplying doesn't work. So let's talk about how you can look at solve an inequality by looking at it graphically. So as we look at this first one, let's start. Where are your x-intercepts? So remind yourself your x-intercepts happen when the top is set equal to 0. So x plus 3 means that x actually equals a negative 3. X minus 2, the opposite, x equals a positive 2. And x minus 7, when you set that equal to 0, means x equals a positive 7. If we think about, you know what, I missed something. What did I miss to begin with? Notice there's something there on the top and the bottom. So that actually means that 2 is not an x-intercept, but rather it is a hole. There's a hole at 2. And then remember, if you plug in 2 into that equation, so like that simplified 2 plus 3 squared plus 2 minus 7 all over 2 to the 4th, 2 plus 8, we can get the y value of that hole, which I'll be quite frank, I don't know. 5 squared is 25 times a negative 5, all divided by 2 to the 4th is 16 times 10. So I think we get some fraction of like negative, yeah, so this is negative 125 over, I believe, 160, so you end up with like negative 0.78. So I do prefer in the fraction form, but for graphing, I think it's going to be easier that we call it negative 0.078. So then let's talk about the next part, like your y-intercept. So if I now plug in zeros for my y's, notice you'll get like, it doesn't matter if we plug into the simplified or unsimplified, but we get like 0 plus 3, so we get 3 squared, and then 0 minus 7, so negative 7 all over 0 to the 4th, and then 0 plus 8. But 0 to the 4th equals 0. And anything times 0 means we're dividing by 0, so therefore the y-intercept does not exist. Okay, in this case, if I set the bottom equal to 0, we'll get some vertical asymptotes. At x to the 4th equals 0, will just be x is 0. And then x plus 8, when we set that equal to 0, we'll get x equals negative 8. So x equals 0, x minus 8 are my two vertical asymptotes. Your horizontal asymptote, look at the degree of the top. We've got a degree 5 on the top, and we've got a degree 6 on the bottom. So the degree on the bottom is bigger than the degree on the top. It will always go to a horizontal asymptote at y equals 0. So now let's go ahead and let's graph those things. So as I go through, we've got vertical asymptote at 0 and at negative 8. And then we got a horizontal one at 0. Okay, beyond that, let's think about some of these x-intercepts. We got one at negative 3, and we got one at 7. If you look at things, it should bounce at negative 3, right? Whereas it should cross at 7. We're going to need at least a partial sign chart here, because besides that, I don't really know which directions we're going. So let's think about that sign chart. What do we want on it? We want our vertical asymptotes of negative 8 and 0, as well as our x-intercepts of negative 3 and 7. So now let's simply put in the factors that we've got there. So x plus 3 squared, x minus 7, x to the 4th, x plus 8. You can do the x minus 2 over x minus 2, but just think about those two. The signs of those will always be the same, so then they'll cancel out. So like a negative divided by negative is always a positive, or a positive divided by a positive is always a positive. Okay, so now let's figure out the signs here. So like a negative 10, anything squared actually will always be positive. Even anything to the 4th will always be positive, so those are easy. But now it's talking about like negative 10. Negative 10 minus 7 is negative. Negative 10 minus 8 is negative, so this interval is positive. If I choose a number between negative 8 and negative 3, I get like negative 5. So this is a negative and then a positive, so this interval is negative. If I choose like negative 1 there, I get a negative and a positive. So notice it is still negative, which makes sense because if you look at the equation, x plus 3 squared, notice how it's bouncing off that x-intercept, so therefore it's going to stay in this, either like the same, in this case, the same bottom part. Okay, if I plug in like positive 1, I get a negative and a positive, so it is negative again. Looking again here, if you think about x to the 4th, think about that as an even root. So, sorry, an even power. So on that asymptote, once again, it will come from the same direction. And then lastly, if I plug in something like positive 8, I get a positive positive, so it's positive. If we then go to draw in our graph, we know that when it's less than negative 8, it's positive, so we're in the upper left. Then it is negative, and it stays negative, but it bounces off that x-intercept. In this case, it starts negative, but it goes positive, crossing through that x-intercept. So in this case, since we're talking about here, when the graph is greater than or equal to 0, we're talking about when is our function on the top portion, right, above the x-axis or equal to the x-axis. So in this case, that left portion of it is that, sorry, didn't need a curly bracket, that negative infinity all the way up to negative 8. Then be careful here because even at negative 3, it is equal to 0. So we want to include that. And then since it's a single value, we usually just use a curly bracket to indicate that individual value. And then we have at 7, since it's equal to 0, we're going to use a square bracket and then going to infinity. Notice we used a square bracket on negative 7 because that was an x-intercept, so it's equal to 0. But I use a parenthesis on negative 8 because that's an asymptote, so it's never going to actually be equivalent to that value. So there's our answer. Okay, so let's talk about why cross multiplication does not work here. In this case, notice how we probably would have found this x-intercept, those two x-intercepts, so negative 3 and 7. However, what we would have missed, we would have missed this portion over here on the left because we would not have recognized that since it's just bounded by the asymptotes and not an x-intercept. So, in general, as you're solving these things algebraically, we're going to move everything to, I usually just say the left side, but one side and set it equal to 0. Then we find what we call the critical points. So think about the points that we put on our number line in the problem above, any of our zeros, so our x-intercepts, or our vertical asymptotes. Then we're just creating a sign chart. So let's do a few of these, like maybe just 2, and then I'll have the answer key up as well if you have more that you'd like to go over, but that will at least get you started for today. So let's do this first one. As you look at this, it's already set equal to 0, or greater than 0 here. So we're going to look on the left, and we want to decide those critical points of this rational function. So like, are there any x-intercepts? So since if you set the top equal to 0, you can't do 2 equals 0, so there's no x-intercept. So the only thing we care about is vertical asymptotes. So set the bottom equal to 0. So when you set that bottom equal to 0, you get x equals negative 1. So in our number line, the only key number here is negative 1. And you can think about the factors as being 2 and then x plus 1. So as we go through then and choose a number that's less than negative 1, so it's like 0. 2 is always positive, so I'm actually going to put positive for both parts. But 0 plus 1 is also positive. You know what? I totally messed that up. 0 should be over here on the right, but that is positive. A number that is less than negative 1 would be like negative 2. So then negative 2 plus 1 is a negative. So this is negative. So this part of the interval is negative, this part is positive. So as we think about our answer, we want something that is greater than 0. So we want the part that is positive. So we're going to take this portion over here on the right. Since there's no equal to sign, you can think about that as being the open circle. So we're going to have a parenthesis around the negative one, and we're going to go to infinity. Okay, I'll actually do the next two. So I'll do these two on the bottom. I'll skip B, but if you want the answer to be, the correct answer is -2, 3 with a bracket, if you want to kind of check your work. Okay, on this one, so like on C, we want to set it equal to 0. So I usually just move this to the other side. We definitely could do it vice versa. It doesn't necessarily matter. So we'd have x, 8 over x minus 3, minus 6 over x minus 1. Now you got to make a common is greater than 0. We want a common denominator. So our common denominator would be x minus 3, x plus 1. So multiply this top and bottom by x minus 1 over x minus 1, and this by x minus 3 over x minus 3. So we'd end up with 8x minus 8 over x minus 1, x minus 3, minus 6x minus 18 over x minus 1, x minus 3, still is greater than 0. So now let's go ahead and simplify the top. So we're going to do 8x minus 6x is 2x. But then you do -8 minus a -18, so that's really like plus 18. So we get plus 10 all over that x minus 1, x minus 3 is greater than 0. All right, so on our number line, if I find the x-intercept, so I set the top equal to 0, 2x plus 10 equals 0 means that x equals, you got it, -5. Okay, and then if I think about my vertical asymptotes and I set the bottom equal to 0, x minus 1 equals 0 means x equals positive 1, x minus 3 equals 0 means positive 3. All right. You definitely could, if it makes your life easier, call the top of this 2 times x plus 5 for the record too. Never hurts to write something like that, especially to recognize if there's any holes. So we've got 2x plus 10, or 2 times x minus 5, x minus 1, x minus 3. So choose a number smaller than -5, like -6. This is then negative times a negative is positive times another negative still means it's negative there. Let's choose a number between -5 and 1. Let's choose 0. So we get a positive, negative, which makes that overall interval positive. Between 1 and 3, we got a 2. So I got a positive, and a negative. So that interval is negative. And this last interval should be positive, but we can always double check by plugging in a number like 4 plus. We're good to go. But since there is no multiplicities on these, they should change like plus minus. In this case, we want where it's positive again. So we want this positive parts of the interval. It is not equal to, so we're going to have open circles. So our interval will be from -5 to 1, and then 3 to infinity. For the record, if it had been less than, the only difference is you want the negative portion. And then if it is equal to, then you